Wormholes. Along with traveling at the speed of light, they're the most popular way of traversing long distances in just about every science fiction book, movie, or TV show. Now, this makes sense, because wormholes allow you to time travel and get across vast distances very quickly. Also, a bonus with wormholes is that it doesn't really break the laws of physics, it just bends them a lot, whereas lightspeed travel kinda snaps them in half. But just because they're popular doesn't make them real. So, are wormholes real, and can they be used in real life? Here's the short answer. No. We have no proof whatsoever that wormholes exist, even though they were theorized and proven mathematically. Sadly, this does not mean that they exist in real life. So there you go. Research project is done. Gonna go on vacation, and I'll see you in 7th grade. Well, as it turns out, they also haven't been disproven. So, just gotta take off all this sunscreen and do this whole research thing.
One eternity later.
Okay, I've done my research, and here's what I found. Wormholes are a pain in the butt. I mean, they probably don't exist. All the equations that people use to prove them are way too complicated, and no one's ever made a Wormholes for Dummies book as just a nice bonus. Okay. Well, I mean, this is for school and it's for a grade, so alright, I'm gonna try. So, here is a quick and way overcomplicated definition of wormholes. Wormholes are a tube through separate places that can be used to connect space-time that has been curved to allow shorter passage between two places and times that were proved by Einstein's theory of relativity and his field equations that is caused by a black hole spreading out of singularity so that there is no one point of mass gravity and is kept from instantaneously collapsing in on itself by negative mass, which is basically impossible to retrieve, and also causes the space-time around the edge to be crushed so close together to create a hydrogen bomb-level explosion that releases huge amounts of heat and energy in the form of radiation that would kill all nearby life forms and cause horrific damage to all nearby matter! Ta-da! That's all you need to know. And I'll admit that probably made about 0 sense. And it wouldn't have made much sense to me at the beginning of this project. But my goal is that, by the end of this video, you'll be able to understand about 87.6% of all that science jargon. Let's get to it! Okay, I should probably get a few definitions out of the way. Wormholes, according to Google, are a hole made by a burrowing insect larvae or worm in wood, fruit, books, or other materials. See, that's what happens when you just copy and paste definitions into a script. Okay, under physics, it says that it is a hypothetical connection between widely separated regions of space-time. They were first theorized in 1921 by Hermann Weyl, and Hermann is spelled with 2 N's, just so you know, as an alternate solution to Einstein's field equations. What are Einstein's field equations? I hear the viewer who always has the right questions thinking. Well, here they are! Look at them in all their glory. Now, one may think that because it's so small and seemingly simple, it would be easy to solve. Just plug in your variables and you're done. Yet, not at all. Even one little variable in this equation could take a well-trained physicist an afternoon to solve. So I won't be going too far into that. But some very smart people have used them to discover some pretty amazing stuff, like wormholes. Another solution to this equation is a black hole, something I know Geo has already talked about, so I'll be brief. Remember how Geo showed the one point of immense mass by pulling down on his cardboard to show how space-time would be pulled down? Well, the way the wormholes work is by taking that kind of curvy cone thing and spreading it out to make a full tube for matter and energy to go through. Again, this is all completely theoretical and doesn't make sense to anyone else, so don't feel left out. Then, this tube is connected to another point in space-time that has essentially been folded over or curved to make it closer. So this creates a hole through the places in space-time to connect the wormhole.
So, let's say that you are a two-dimensional being. Somehow. I don't know. I don't know what you did, but now you're a two-dimensional being. and you live on this two-dimensional piece of paper.
A piece of paper isn't two-dimensional. It has a height.
Bryce, I know I can't create anything that is actually two-dimensional, and even if I could, we definitely wouldn't be able to see it, so this is as close as I'm willing to get. Okay? So, now that we've got that out of the way, let's say that you have your little two-dimensional car, and you're at this corner of the paper, and you want to get over to this side, or to this corner of the paper very quickly. But this distance is 100 miles, and the speed limit is 10 miles an hour. So it'll take you 10 hours to get from here to there. But the way that wormholes work is you basically fold up this, your space-time, in this case it would be two-dimensional, and then you take this three-dimensional object, the pencil, and you can kind of poke it through, and then pull them apart. They might rip. Oh, that was good. And now, it's much quicker to get from here to there. It's just this little distance instead of going all the way around the whole 100 miles. So this is how a wormhole works. Now, keep in mind that we're using a pencil, and this paper represents 2 dimensions, and this pencil is 3-dimensional. So we're adding on another dimension. Now, since we live in a 4-dimensional world, we would need a 5-dimensional object to create a wormhole like this.
We don't live in a 4-dimensional world. We live in a 3-dimensional world.
Okay, so we do have 3 normal dimensions, length, width, and height. But also, in physics, we usually also call time the 4th dimension. Even though we can't travel forwards, backwards on this dimension, we still travel on it, and wormholes allow us to time travel, so we'll definitely need to be able to travel on that dimension. So anyways, thanks Bryce. And also, we would need a 5-dimensional object. Now, in A Wrinkle in Time, that object is called a tesseract. Now, we don't really know how to make this. I mean, you're not just gonna walk up and, hey, go up to Walmart and buy your all-new tesseract to create your own homemade wormholes. No, we don't know how to do that. And also, this paper would represent our space-time, which I've already talked about. And when we fold it up, it's kind of like wrinkling the space-time, and hence the name A Wrinkle in Time is the name of the book, because they're wrinkling space-time.